This is the sub-program to determine the best press fit you can do in a three-ring or three-component die assembly. That can give you the maximum tool life, and also to make sure that during the forming operation, none of the tool components break and have a good life. So if we look at this picture here, we have the insert, the die, and then we have a middle insert, and then the casing. Now the procedure that we are analyzing here is where the middle insert is put in the casing first, and then the insert is pressed fit into the assembly of middle insert and the casing. What we want to find out is the press fit that we should give at each of this stage that would give us the maximum or the best tool life. So those materials we are going to select here. I've already selected those from the drop down. The carbide here that will bring up the modulus of elasticity and Poisson's ratio. And same thing for the middle ring. It's an M2 steel that I have selected, and for the casing is 13. And these are the properties that the program would bring in. Here you will enter the radius, not the diameter, but the radius. This is the inner radius, this is the outer radius of the insert, inner radius of the middle insert and the outer radius, inner radius and the outer radius of the casing. Now if you have a taper die, you can just take the middle of that as the diameter, and of course you will not have the inside as a straight diameter, so you just take the mean or take the maximum, one of the two, and put those dimensions here. You would here select the amount of interference you are going to put. Let's say we put 5,000 here on the radius, and the interference between the casing and the middle insert, let's say 5,000 as a starting point. And in order to see the stresses, we are going to select these stresses here. And for the time being, let's say there is no pressure from the inside. We are just going to look at initial assembly. When we assemble it, what would be the stresses? If you click on this, you would be able to see the stresses in the insert, middle insert, and the casing. And the value of this insert, if I'm looking at this yellow curve, which is the maximum, if I look at that value, that maximum should be less than the yield strength of the material. So if I look at the insert, it's going to be 191,000. I have to multiply 1,000 with this. So many psi, and that is almost near where the yield strength, tensile yield strength of the insert might be. So I want to make sure that I do not put more compression here or interference here, so that this would go beyond 200,000, and rest of it they seem to be low anyway. So this is the condition when I don't have any pressure inside. I just have assembled the tool in the press. If I find this is too much, I can go and reduce the amount of interference and calculate it again. And as you can see, by changing it from 005 to 004, I have reduced that amount. Of course, I have reduced it here, but when I put the pressure, then at that time I'm going to need more interference. So I have to balance it between what the stresses are going to be when there is no pressure and when there is pressure. So I'm going to put the pressure here from the inside. This is when we form the part, there will be pressure. That pressure, let's say I take it 100,000, which of course I would like to have maximum that my tooling can stand. And now I can look at it again. So if I put that pressure, I can see that still I am below that 200,000. That means I can put definitely 100,000 psi without any problem. But let's say I go to 150,000 psi. I can again look at the stresses. Now the stresses are getting more. If I go even beyond 150,000, let's say 200,000, then it is going beyond the limit because I want the circle to stay within plus 200 and minus 200. So that means I would not be able to take 200,000 internal pressure because my tools would yield. So I can, by changing these numbers, the interferences, I can figure out that setting which would not yield the tools without any pressure. That's when I press it. I don't want to overpress it there. And and with that setting, I can see how much maximum internal pressure I can put in. So I can sort of optimize my settings as much as I can to keep the stresses as low as possible. Of course, the main purpose of having three rings is that we want to distribute the stresses from the inside to the outside. If I have only one component, I will not be able to adjust it. By having three pieces, I can adjust it, move the stresses from the inside to the outside, and have a balanced stress throughout the cross section. That's the main purpose of the three ring die assembly. And we can adjust it to the best using this subprogram.